Okay, so thanks for joining, guys. So let me take the last class that we have discussed, which is about turtle sim, right? So I have just updated that video. You can able to watch it. It's here, and so that was the last topic in the first chapter. Okay, that is kickstarting robot programming using ROS. So today we are starting with the second chapter. Okay, we are starting with the second chapter, which is programming with ROS. Okay, so we have discussed some of the concept in the first chapter, but maybe we can see all these things again in this chapter. Okay, so in this chapter we are primarily focusing on how to implement the ROS concepts. So you have learned a lot of ROS concepts, right? Like ROS topics, then ROS services, ROS actions, ROS parameters, then ROS master, all this stuff. Okay, so how to implement this? Okay, in a programming language, using a programming language. So that is what we are seeing in the programming chapter. Okay, so before starting the programming, we will first talk about what is a ROS workspace and packages. Okay, how to create a package and how to use an existing package, all this stuff. Okay, then we will be discussing about the client libraries, which is very important. Then we will be like talking about ROS launch, ROS bag, and then we will start implementing the ROS concepts. Okay, and my plan is that I have some sample code with me, mainly the basic code. Okay, basic code like publishing, subscribing, and there are some sample code which is interacting with turtle sim. Okay, so you may be thinking like what you will get if you work with this basic project. The thing is that while you learn ROS, it is very important to understand the basic concepts. Okay, if you have any confusion in the basic concept, then you can't proceed to the upcoming topics. Okay, so that's why you have to do some sample projects using ROS programming, basic programming. Okay, and using turtle sim. Okay, yes, so let's start with the ROS workspace and packages. Okay, so that is the first topic that we have. So I have the Ubuntu system with me, which is running on 20.04 and Ubuntu, ROS Noitic. Okay, so let me start with the workspace. So anyone know what is a ROS workspace? I actually mentioned about ROS workspace in the previous session. Can anyone just mention what is a ROS workspaces? Anyone? Any idea, guys? Okay, so if you don't have any idea, then maybe I can explain. It's not a big deal. So ROS workspace, from the name itself, there is a terminology, the workspace, right? So workspace is a folder in which we are organizing our ROS package or ROS software simply. So we can have multiple workspaces. So mainly from my experience, I will be creating a workspace for a robot, maybe a one robot, and the software of that robot will be in that workspace. Okay, and maybe I will create another workspace for another application. Okay, so if you put all the software in a single workspace, then it will be too crowded and it's very difficult to like understand what is going in the workspace and all. Okay, so better will be like create a workspace for some application. For example, if you are learning ROS, then I will prefer you to create a workspace can be created at any location, but I will say better will be creating workspace in the home home folder, which is like if you take the files and the home. Okay, so simply you can either create a folder from the command line, or you can simply do it from like this: new folder. Okay, then I'm just creating a workspace folder called learn ROS. Okay, learn ROS workspace. Okay, so this is a workspace folder. Now I'm creating it, and then there is no folder inside it, obviously. And what you have to do is, in order to create the workspace, actual workspace, you have to create a folder called src. Okay, src. Okay, so this is the structure of a ROS workspace. Okay, you can create a folder, and inside that there is an src, and inside this src we have to keep the ROS packages or ROS software. Okay, inside the ROS packages we can keep our ROS nodes. Okay, so ROS package is like I will say the atomic unit in ROS. So each software in ROS is actually inside a ROS package. Okay, so inside this workspace we are keeping the ROS packages. Okay, so you can create a new package, you can copy the existing package to the workspace. Okay, or you can do all this stuff. So maybe what I can do is, currently there is no packages, simply it's empty, right? So so why we are creating a package, why we are creating a workspace? That is the another question, like why we have to keep everything in a package workspace. Obviously it will create some structure for the software, but that is not the case. The workspace is where it's actually using for building the software. For example, I'm just switching to the workspace folder. Okay, and then the workspace is from the workspace folder I can able to build the ROS programs. Okay, so the building is only required for C++ files. Okay, so if you are creating ROS software based on C++, then you have to build it. Okay, otherwise if it is a Python program, okay, then it may not require catkin build. Okay, so if there is no package in the workspace, even we can build it. Okay, we can build it. So we have to use a command called catkin_make. Okay, catkin_make. This is very important. This is the command we are using to build packages inside the workspace. Okay, so inside the packages there will be C++ file, Python file, and custom messages, custom service, custom actions, all this stuff. So using the catkin_make, we can build all those packages. Okay, and even if there is no packages, it will actually create some folders, or it will create some folders which can be used for the future building. Okay, future build of packages. So if I enter catkin_make, catkin_make, okay, then it will show some messages. Okay, and let me take the workspace, and you can able to see we only created the src folder, right? But now we have two more folders, which is build and devel. Okay, so these two folders actually created by the catkin_make. Okay, catkin_make is a single command in order to build all the packages, and you may have some confusion. What is the catkin_make? What is catkin? So it's simply, if you just search for ROS catkin, you will get the wiki page for catkin. Basically, catkin is a build tool. Okay, it's a build tool, means that uh, means we can able to build the ROS packages using this tool. Okay, you may have heard about the CMake, right? CMake is actually a build tool, but Catkin is actually I mean it is using CMake. Additionally, it is using some more script. Okay, so that is actually Catkin, and using Catkin we are able to build the ROS packages. Okay, so the Catkin make is a command in order to build the ROS packages. Okay, so the build and devel, okay, there is two folders, build and devel. So devel, mostly it is having the executables, like if you build a ROS package, and if it is having C++ files, the executable mostly store in the devel folder. Okay, executable, the library files, all those stuff will be in the devel folder. Okay, and there is also some script in order to make the packages visible inside this workspace. So I will mention that. And build is having like some temporary files of the CMake list. So if you just check, you can see some cache files and all. Okay, so why we use the build is that build is having these cache files. So whenever you run the Catkin make again, it will be using these cache files. So that will be reduce the entire time of building. Okay. So so these are the two folders that is created, and yeah, so currently we don't have any any packages, right? So the next thing that we have to that we are going to see is how to create a package. Okay, and let's see how to do that. So in order to create a package, what you have to do is there is a command called catkin create package. Okay, catkin create package, and catkin underscore create underscore package. Okay, and after doing this command, after typing this command, you have to give a package name. Okay, so I'm giving a package name like learn ROS. Okay, so this is the package, and then what I am doing is I'm just giving its dependencies. Okay, so the dependencies means in order to build this package, you need to have following package installed on your system. Okay, so the dependencies are like when you install ROS, there are some packages are already installed on your system. So in order to work with this package, maybe ROS CPP is one dependency. For example, if you are working with ROS and C++, you need to add a package called ROS CPP. Okay, I will be talking about ROS CPP after some time. Then ROS Py. So if you are planning to work with ROS and Python, you have to add this. And if you are planning to use some messages, standard messages, or the messages that is already available with ROS, you have to add that package as well. So currently we are just adding standard messages. Okay, after adding this, just press enter, and you can able to see, oh sorry, it's actually have to create inside the src folder. Okay, so it's not from the workspace, you have to switch into src, then only you have to create this package. Okay, so I am just entering the command again, and the command is actually creating the package called learn ROS. Okay, so we have the package, it's pretty empty, there is nothing. and so we can able to build it. Even if the package is empty, we can able to build it. So in order to build, just come to the workspace folder, and you can able to see, yeah, it's building, and you can able to see the package here. Okay, and yeah, so that is actually I mean, how to create a workspace and how to create a package. Okay, and one more thing is that currently this workspace, okay, this workspace is not visible to the ROS environment, meaning if you want to run something from this package, currently it is actually not visible. Okay, so in order to make this workspace visible, you have to do this command, okay, all the time actually. Otherwise you can add it in the .bashrc. Okay, I can explain the thing. So this is the command that you have to execute in order to make your package visible. Visible means then only you can use the ROS run command to execute the node. You can use the ROS launch command to execute the launch file. Then you can use the ROS cd to switch into that package or something. Okay, so what you have to do is, after creating the workspace, immediately you have to add this line to the .bashrc file. Okay, so just open your .bashrc file and then just go to the end of the bashrc and add this line. Okay, so if you add this, and whenever you create a new terminal, this sourcing will be working. And then what you can do is, if you do ROS cd learn ROS, then what you will get is, you will go to the learn ROS package. Okay, okay, so this is how we create a workspace. After creating the workspace, make sure you have sourced the workspace. It's very important. Okay, most of the issues, like if you try to run a node inside a package, and if it is showing some error or something, make sure you have source it. Okay, which is one of the important point to remember. Okay, okay, so now what we can do is, we can see what is the package and what are the files inside it. Okay, so this is a sample package, I mean it's a package template, and you have to put your software, ROS software, inside this package. ROS software means the source code. Okay, so in a package, by default, when you create a new package, you can see these files. This is actually the basic files, or I will say the mandatory files you will be seeing in every package. Okay, so these two files will have the information about the package name, then the dependencies, then the author of the package, then the CMake list is having again the dependency of the package, and also the commands to create the executable from the source code, like C++ and all. Maybe I can explain that. So let's see what is the package.xml. Okay, so this is a default package.xml that you are getting when you create a package. Okay, and what are the things inside it? You can able to see. It's an XML file, obviously, and there is a package name, then there is a description, then there is a maintainer, license. All these are like template, you can modify it. Then there are some tags like build depend, then build export depend, then exec depend. Okay, so build depend means these packages is depend, I mean, it is a must for building this package. Okay, like if you want to build a C++ file or something, then this package is a mandatory. Build export mean if you are planning to export this package like a library or something, plugin or something, you may need this package. Okay, and exec depend means if you are planning to execute the nodes, and whenever it is executing, these packages are mandatory, like that. Okay, and there is an export tag, so which is using when we write when we start writing plugins and all. Okay, plugins, planners, or planners are, I mean, if you are working with ROS and planning to write planners, we need to use this export tag. Okay, so yeah, so these are the things inside a package or XML, and I will suggest you to clean up this package or XML. Okay, so that will be good for maintenance. Okay, so you can clean up and just add the necessary stuff into the package or XML. Okay, yes, so that is a thing. And so the package or XML is the main file. Like whenever we run the catkin make, it will be first checking the package.xml, and if the package.xml is not available, then this package will not be considered. Okay, this the catkin make will not have an idea about this package. Okay, and next is a CMake list. Okay, so basically this is the heart of the ROS package. I will say it will be the heart of ROS package, because the CMake basically using for compiling C++ files. Okay, and also imagine if you want to create a custom ROS message. You know what is a ROS message is, right? Like string, integer and all. So if you want to create a custom ROS message, then you have to use a CMake to generate corresponding headers file for that. Okay, that is actually upcoming topics, and you need to have these things, catkin package, which is actually a ROS macro, which is required to build the packages. Yeah, so that's it. I mean, there is not much things inside it. Okay, but you have to customize this this file in order to make it work with I mean, you have to customize this for compiling and building the messages. Okay, so yeah, so that is the CMake file. Okay, and now there is src and include, which is basically for keeping your source code. Okay, basically keeping your source code. So maybe what I can do is I can just show you how to maybe how to edit the CMake list. Okay, and add the talker and listener.cpp file into the src file. Okay, I have the code already. Okay, we will discuss the code, but I was just showing how to create the package and how to edit the package. Okay, so I have all the code in another folder called, I mean, package called hello world. So what I'm doing is I'm just copying that listener and talker from here, and then I'm copying into the src folder. Okay, so in order to make it faster, okay, otherwise I need to write it and all. So I'm just copying, and then so we have two C++ file now. Okay, so what is next? You have to edit the CMake file. Okay, so editing means first you can just clean it. Okay, so these lines, you know, these lines are like comments. Okay, so mostly these comments will not be used initially. I mean if you uncomment it, we can use that, but initially we don't need it, but gradually we can add the required things. So I'm just adding these things, and I just need this. So basically, if you remove all these comments and all, you will be able to get the compact form of the CMake list. Okay, I can remove all these things. Okay, so you can see it's very simple file. Okay, it's a very simple file. And then what you have to do is we have two files, right? Talker and listener. So now you have to compile the program, right? So how to do that? That is the next question. So in order to do that, maybe I can show you. So I'm just taking the CMake from the other. Yeah. As of now, you can able to see, like, in order to compile the CPP file, we are actually using the CMake list command. Actually, the CMake is having these commands for creating executable, add executable, target link library. So these two lines are using to create an executable from a CPP file. Okay, it's actually inside, the code is actually inside the src folder. So we have to mention src/talker.cpp, and this is the executable name. So when you compile and build the talker.cpp, you will get the executable called talker. Maybe we can change into talker test. Okay, talker test. And also this is what the first step is compiling, and this is actually linking to the libraries. Okay, so I am also changing the listener test, then listener test. Okay, so you can just keep all these things without any modification. What you have to add is these two lines in order to add a CPP file. Okay, I'm talking about CPP file now. For the Python file, I can discuss later. So yeah, we have done that. And then if you build the package, okay, I'm just going back to the workspace folder, and then I'm just going to build it. Okay, so you can see it is actually building, right? And you can see it's created an executable called talker test and another executable called listener test. Okay, then what I'm doing is I'm just going to run that executable. So first I have to run ROS code, and then ROS run package name, that is learn ROS, and talker test. So now it is running the talker test, and then ROS run learn ROS listener test, that is the executable name. So the listener is now running. Okay, so this is what we do in order to compile a CPP file. Okay, CPP file which is having the ROS APIs, okay, ROS functionalities. So I hope that is clear to you. I can give you the examples. So it is just a matter of like putting your C++ code, then just edit your CMake list.txt. Okay, so just let me know if you have any doubts regarding the editing of a package and adding the CMake list. Let me know if you have any doubts.
Sir, one doubt. Do we need only one workspace for entire ROS operation, or what is the requirement of creating new workspace, extra
Yeah, I
workspace?
think I have mentioned that, like, it's depend on the application, I will say. Like, for example, you are doing a ROS project, okay, and the ROS project is like maybe I am pick and place or something. So you have 10 packages related to this project. Okay, so it will be better to put the similar packages in a workspace. Okay, then for another purpose you can create another workspace. So it's no there is no need to create workspace all the time, but it's based on your it's I mean basically we are categorizing a list of packages. So for a project you can create a workspace, and for learning ROS maybe you can create a workspace like that. So the similar packages will be in the workspace. Yeah, is that clear?
Yes, yes. One more doubt, sir. What is actually the difference between creating a package and building a
Yeah.
package?
Okay. So the question was like, what is the difference between creating and building package? So the thing is, creating package means we are creating a template of a package. Okay, we are creating a template. I think you have seen that when we will get a folder called the learned ROS. That was the package name, and then we have to insert the ROS programs into it. Okay, and then the building of the package means, okay, when you do the catkin make, okay, catkin make. So this is what the building of the package mean. When you uh, execute the catkin make, then this command will check the src folder, meaning this this src folder inside the workspace. There is an src folder, so it will check this src folder, and it will go to each packages. It will check the CMake list, and it will build the C++ files, C++ program, and create executables. So building of the a workspace means we are creating the generating the executables from the C++ files. We are creating the header for custom messages that is actually coming. So that is actually the building of the workspace means. Yeah, is that clear, Hari?
Yeah, thank you.
Do you have any other question? Because these things looks very very easy, but when you start working on it, you will feel the difficulty. So if you have any question, any more question, let me know so that we can discuss and move on. Any confusion? Okay, okay. So I think you got the point, like the CMake list. Yeah, so currently what we have done was we have created a package. Okay, what about copying an existing package? Okay, so that is the next thing that we are going to do. So let me see. Yeah, so I am actually copying a package, maybe. Yeah, the problem is that imagine you have two workspaces. Okay, two workspaces, and in these two workspaces you can't have the same packages. Okay, if you have same packages, then it will ask which package that you are looking for. Okay, so make sure you are not having multiple copies of each package in multiple workspaces. Okay, so I mean, you can simply copying the package mean you can simply download or copy a package from internet. Okay, and then put it in the src folder. Okay, then build it using catkin make. So for a demo I can show this, like hello world I just copied, and then I'm doing the catkin make. Okay, so it found two packages, learn ROS and hello world, and now you can see it is building the package hello world. Okay, after building, it is basically creating the executables. Okay, so yeah, so that is what building of the package means, or building of the workspace means. Okay, yeah, so I think you got some idea about the workspace and packages. Okay, so now we are jumping into the client libraries. okay, which is very important. So I'm going to show you, I'm going to open the talker.cpp program. Okay, talker.cpp program. Just a second. Okay. So can anyone say what is the talker.cpp does, or what is the talker executable does? I think we already discussed that. When we run the talker, what is happening? Anyone? Any idea when we run the talker? Yeah, Kalpesh.
Publishes
Yeah, Kalp.
like it publishes a
Okay.
topic,
Yes.
and the name of the topic is
Okay.
chapter.
Okay. Hari, any more point?
Inside that topic, message hello world will be.
Yeah, message. The message type is string, and data
Yeah.
is hello world and account, right? Okay. So yeah, thanks for thanks for that. And basically, what we are seeing is the code of the talker program. Okay. So this is a C++ version of the talker. Okay, and we have the Python version as well. So after discussing the C++ version, we can discuss the Python. So I mentioned that there is a ROS concepts like topics, messages, action, service, all this stuff, and we can implement these concepts in programs. Okay, so what we have is, if you just search about ROS library, not ROS library, just a second. Yeah, ROS client library. You will get again a wiki page, and this is what a useful read for you. Actually, I'm just sharing the link. Anyone have any idea about what is a client libraries? Any idea? ROS client libraries? Any idea? Any idea? This is actually very important and very useful. Okay, maybe I can explain. So client libraries are, again, from the word itself, there is a library, right? So these are the libraries available in each programming languages, and these libraries, we can use these libraries in order to implement ROS concepts. Okay, for example, I am writing a program in C++. If I want to create a publisher, I can able to do using what? The client libraries. Imagine I am writing a Python code, and if I need to convert that program into a ROS node, and then I need to publish a topic, then subscribe to other topics. The basic ROS stuff. If you want to do, then you have to use what? You have to use the client libraries of Python. Okay, so the client libraries is the libraries which is having the ROS concept implementation. Okay, very important point. So you can able to achieve the inter-process communication, that is publishing, subscribing, services, action, using the client libraries. Okay, so if you check this page, you can able to see the main client libraries are ROS CPP, ROS Py, and ROS Lisp. Okay, ROS Lisp we are not using much. Mostly like we are focusing on ROS CPP and ROS Py. Okay, so the ROS CPP is having complete APIs. Okay, it is having APIs that is having the all features of ROS, implementation of all ROS features. Okay, the ROS Py, it is having lot of implementation, but some are missing. Okay, maybe I can say 90% or 85% of the ROS concept implementation is there, but some, I mean, it's not like ROS CPP. Some concept we can't use ROS Pi. Okay, but ROS Pi is very, very popular because if you take any courses in the internet, like the construct or something like that, they mostly are going with ROS Pi because it's easy to get started. Okay, but the problem is that if you're going with ROS Pi only, okay, then when you are going to work with some important concept in ROS like ROS nodelets, plugins, controllers, all this stuff, then you can't do anything. Okay, so what I will suggest you is that learn both, okay, but focus more on ROS CPP because if you are working on perception side, okay, imagine if you are working on the perception application, I think ROS CPP or the CPP will have advantage on the performance. Okay, so that's why ROS CPP is important. Okay, so I will in this course we are focusing on ROS CPP, but we are also discussing ROS Pi. Okay, if you have an idea about ROS CPP, you can easily work with ROS Pi. Okay, now there are some experimental client libraries. So if you are using C Sharp, then Java, Android, Lua, R, then Unreal, I mean almost MATLAB, there is some client libraries. Okay, mostly those are experimental, but I will say the Node.js, Java, all these things are very good. Like the basic implementation is actually very stable. Okay, so so these are the client libraries, okay, which is having the ROS implementation, and we can use the client libraries function to create ROS based application. Okay, and yeah, I think you got an idea about the ROS client library, and we are focusing on ROS CPP and ROS Pi. So if you just go to the ROS CPP, then you can see the ROS CPP page, and yeah, I mean there is nothing much, but there is tutorials, ROS CPP tutorial. Do you remember the ROS CPP tutorial package? Do you remember this package? I actually use this package a lot, okay, ROS CPP tutorial, because you will get this package when you install ROS, okay, and it is having the tutorials for creating a publisher subscriber, which is basically talker and listener example, then symbol service and client parameters, then yeah, I mean most of the stuff are there in the tutorial. Okay, so this code explanation, everything is available in the ROS wiki, but initially you will have some confusion when you start working, but mostly I am also depending on this tutorial. Like after even working with ROS for a long time, I still depend on the tutorial to get the templates, okay, to get the template code for a node. So this will be useful, guys, the ROS CPP tutorials. Okay, I'm just sharing. Yeah, I already shared. Okay, so let's go back to the code. Okay, I'm also opening the listener code. Okay, after this we can explain the ROS Pi. So can anyone explain the logic of this code? Logic in the sense, I mean, you don't need to explain the exact meaning of these lines, but can anyone explain what is actually going on with this code? I mean, maybe line by line you can simply mention the idea. What is going on this line, what is going on here, then what is going on this loop. Anyone? And also here. Any idea about this? Okay, maybe I can explain. It's very simple actually. We work with Docker listener a lot. So basically, the if you check the header files, you know, the ROS head. I mean, if you work with C++, you may be using IOStream for input output, right? Input output function. So if you check this code, you can able to find row/rows.h. Okay, row/rows.h. So this is what the client library is. Okay, so in order to access the functions inside the ROS CPP client libraries, you have to use the rows.h. Okay, rows.h. So this is the important header file that you have to include in any of the CPP ROS CPP program. Okay, so in order to access the ROS CPP client library function, what do you have to include? It's row/rows.h. Very important. Don't miss this line. If you miss this, then you will get tons of error. Okay, so this is the header file, and by including this header file, you can able to access all the ROS CPP functionalities. Okay, so what are these functionalities? I already mentioned in the client libraries, we have functions to create a publisher, we have function to create a subscriber, you have you can able to create services, you can create parameters, then yeah, like that, everything related to ROS. Okay, so let's see what is going on. So first, rows.h is included, so we got all the ROS superpower. So now, can anyone say what is this? Standard message /string.h. Any idea? Any idea, guys? What will be the string.h? Okay, so maybe I can explain. I already mentioned that the standard message is a package. So if you want to know about the standard message, like just search in internet, standard message ROS. Okay, so this is the package that is giving by ROS. Yeah, ROS. It's already included in ROS. Okay, so standard message is having standard message types. Okay, like Boolean, integer, float, string, arrays, and all. Okay, so if you want to send a string, okay, then the message type is already there. So the string message type is already there in standard messages. So what you have to do is you have to just include that in the program. Okay, again, it is important because you need to include the header files of these messages. Okay, so what happening is that, so you may have some confusion. Why the string.h? Why string.h? Why why the message is put it in the header file? So what happening is that in ROS you can create your own message. Okay, your own message. So currently we are sending a string, right? You can send a string and integer at the same time, or you can send string, integer, image, or anything at the same time. So it's like a structure. It's like C struct. It's like we can keep different kinds of data type inside a single entity. So ROS messages are like struct. Okay, you may have seen the ROS, C struct. So basically in the struct we can keep any kind of data type. Okay, so the ROS messages are like struct. Okay, it's actually struct. Okay, so when you create a ROS message. Okay, I will show you how to create a message and all. It's very simple. ROS is actually creating a header file corresponding to that message. Okay, and this header file will have the the struct corresponding to that message. Okay, so that is what the standard message string is. If you want to include integer, then you have to do like in 32 or something like that. Okay, and SS stream is actually a standard library which is actually for string manipulation. Okay, if you want to add a count along with the string, we can use the SS stream buffer. Okay, so let's start from the in main. Okay, so I think you got an idea about the header files. Now starting with the init. Okay, so you can see there is a namespace called ROS. Okay, ROS is a namespace. Okay, inside this namespace we can able to see like functions like init, node handle, publisher, rate. All these are from ROS namespace. Okay, can anyone guess what is init? Any idea? ROS init?
It's an initializer.
Yeah, initializer of what? Initializer of what? Any idea? Initializer of what?
Basically, initializer for any of the ROS message types, or it's used to establish a communication channel between the different ROS nodes. So
yeah, there is, yeah.
And for in the current perspective, it is initializing the Docker node.
Yeah. So that's what, like when you start writing a ROS program, the first thing that you have to do is you have to initialize the node. Okay, the node. Then only the program will get an identity. Okay, so the init will be basically starting a node. Okay, it actually starting a node. So this is actually the syntax for the init function. So init rgc rgv, which is a command line argument, and you have to give the name of the node. Okay, which is talker here. Okay, you can give any name. So this is how we are initializing the node. Okay, so now what we have to do is we have to publish a topic called chatter. Okay, so in order to create a topic, okay, this is what we have to do it. Okay, so first you have to create an object of a thing called node handle. Okay, so node handle, what is node handle is that using this node handle we can able to create a publisher, you can create subscriber. Okay, you can create services. All these things we need to have a node handle. Okay, node handle object. So node handle is a class and n is actually the object. So after creating the object, here is the important line. Okay, in this line we are creating a topic, and this topic is for the publishing. Okay, so this is a publisher. So this is how we are creating a publisher. Okay, there is a class called publisher, okay, from ROS namespace, and we are creating an object called chatterpub, and here this is what the things of the things of the topic, like things in the sense the name of the topic, type of the ROS message flowing through the topic, then there is a queue size. Okay, queue size like a buffer, and advertise means publishing basically. Okay, so this actually return a publisher object. Okay, and that publisher object is storing in chatterpub. Okay, and using this chatter pub, you inside this chatter pub object there is a function called publish, and then we can able to publish it. So I can show you the functions inside the ROS CPP. You can see here like ROS node handle is there. Then so if you take the ROS node handle, you can able to see the advertise service. Then all the functions are inside the node handle. Okay, so it is very important to create a node handle, then only you can access all the functionalities of a node. Okay, like publishing, subscribing, parameters, all this stuff. Okay, so what we have done here is we have created a publisher which is having standard message string type, which is having name of chatter, and this is the buffer size. Okay, because it is actually sending the data in a queue. Okay, so this is a buffer size, and we can change everything. We can change the queue size, we can change the name of the topic, we can change the type of the ROS message. Okay, all these things we can change. And then in these two lines we are basically so there is another class called rate, which is actually for the loop frequency. Okay, so here what we meant was if we use the loop rate dot sleep. Okay, so loop rate is an object of rate class, and there is a function inside this object called sleep. Okay, so if we call this, then this loop, this while loop, this infinite while loop will be running as 10 heads. Okay, so if you want to set a loop in a particular frequency, you can able to use the rate class in ROS. Okay, so now in the while loop what is happening is that there is a function called ROS namespace OK, meaning if there is no termination of, if there is no control C is pressed, okay, then until that this loop will be executed constantly. Okay, it will be keep on executing. But if you press the control C, this loop will be terminated. Okay, and inside this loop, what is happening is that we are creating a message variable. Okay, so this is how we are creating a message variable. Okay, so this is the message, that is std message string, and this is the object or like the variable of the message. Okay, and this message is what we are going to publish through the topic. Okay, so we have the message, and the next thing is we have to populate this message with the data. Okay, here it's a string data. So here we have the message, and then inside this message there is a field called data. Okay, so maybe I can show you that. You can just search about std message string, and if you take this message, inside that there is a data field. Okay, it's actually string. Okay, this is a data type, and this is the variable name. So what we are doing is we are creating a copy of string. Okay, and inside the message there is a data field, and to that data we are giving a string value. Okay, so this line is basically like adding the hello world to a count. So we can see hello world 1, hello world 2, hello world 3. That is actually doing by this. Okay, so the message dot data, maybe I can just remove this, and for better understanding, what I can do is maybe std string data equal to hello world, and I can give that data to this message. Okay, so what we have done was we have created a message, then we have we have um, we have created a data to send. Okay, hello world is the data that we are going to send. Then we have added this data to this message. Then what happened? Then we are publishing this message. Okay, so we are going to publish the hello world, and after publishing there is a function called spin once, which is actually like when you call the spin once, then only it will send. Okay, so the publish will do the publishing, but it will be only execute when the spin once called. Okay, and the loop rate, basically what the loop rate is actually deciding the updating frequency. Currently it's 10 Hz. Okay, so if you just build the code using catkin make, you can able to see the code actually built. Okay, and then if I execute the executable like learn robot, talker test, you can able to see hello world. Okay, hello world, and I can also check the topic. I'm just echoing the chatter, and then you can see hello world. Okay, hello world is the data that is sending. Okay, so that is actually the publisher or the talker. Okay, in the listener side, it's actually very less code. What happening is that these two lines are the same. These two lines we already seen. In order to subscribe, okay, this is the main line, which is actually like there is a object called a class called subscriber. We are creating a subscriber object, and we are creating the subscriber using this line. Okay, basically there is a node handle. Inside the node handle we have a lot of functions to publish and subscribe. So you can see how to subscribe. Like this is the topic name that we have to subscribe, and this is the buffer. Okay, and this is the function whenever a message received in this topic. Okay, so whenever a message received in this topic, then a function will call, or it is calling as a we can call it as a callback. Okay, so this is a callback function. Okay, so whenever there is a data comes to this topic, this function will call. Okay, so this function, what it does is that it will simply receive the message that is received. Okay, actually the subscriber will receive the data, and you can able to see the data like this. Okay, this is the simplest form. So we are getting the string message as the parameter. Okay, so this is how the callback works. It's not a normal function. It is a function without the arguments. Okay, but when it is called, you will get the received data or received message on this variable, and then you can access the data. Okay, so maybe I can just do the ROS catkin make, and then I can run the listener test, and then here the talker test. Okay, so you can see I heard hello world. Okay, so which is what happening here. So ROS info is like for logging the information. Okay, so it is for logging or simply for printing. Okay, so ROS underscore info is a function from ROS.h. Okay, so you can simply put the message data C string, so it will be printing it. Okay, and ROS pin basically like keeping the node in a infinite loop or a while loop. So whenever we press the Control C, it will quit. Otherwise, it will be like keep on listening, Okay, so the duty of the subscriber is it will keep on listening to the topic. Okay, if there is no topic coming, it will still listen. Okay, I mean it will wait for the topic or wait for the data to come. Okay, so that is what spin does. It will simply wait. Okay, and whenever a data comes in the chatter, it will call the callback. Okay, so let me know if you have any question regarding this too. I'm pretty sure that you will have some question, because the first time we are explaining the nodes. Okay, C++ nodes. So it's the time for Q&A. Okay, we can discuss the Python maybe tomorrow or day after that, because tomorrow I have a ROS workshop. So I will be like I will be tired. So mostly I think Sunday. Okay, Sunday night we can discuss. So let me know if you have any questions regarding these nodes. So if you understand the basic publisher and subscriber, you can create a bigger, you can write many publishers and subscribers, and yeah, it's actually pretty complex when you write multiple nodes and all. So it is very essential to understand the basic stuff first. So do you have any questions? Is it clear, guys, or you can ask?
What kind of other classes are there? Like, for example, if it's a subscriber and publisher, so like what others classes we can use for?
Your voice was not very clear, Karan. Can you just repeat, or you can just simply type? Yeah. Okay. Yeah, so Karan is asking a question. What are the other classes? What other classes are there? Like subscribing, publishing. I think I already shared that. It's just above the your comment. I mean, the last link that I posted was that. Okay, so like if you take the last link, you will get the API list. Okay, so this is the class list. Okay, so but we mainly need the node handle. Okay, the node handle, and from that you will get all the things like advertise, then services, then timers, then parameters. Maybe I can share so these are the things available from node handle. So there are tons of APIs. Okay, all these things you can use. Yes. So this is a ROS namespace, and inside the namespace you can find namespace members, member functions. These are the functions available. These are the classes. Yeah, so this is the documentation. So you will get access to the all APIs of ROS from this, mainly the ROS CPP APIs. Okay, main page. Yeah. Okay, so any more questions?
In the beginning, you showed the structure, right? Like we have to save our source code in the
Yes.
SRC folder and everything. So how do we do it? Like, let's say right now we are just doing the simple thing, just like publishing and subscriber. But if we do more complex tasks, then how is it define the project structure?
Basically, like we have to we can put all the CPP nodes in the SRC, and if we have any libraries, for example, if you have any libraries, you can put the header files inside this include folder. And if you have a complex project, what I will suggest to you is that create multiple packages. You have to make it modular. For example, if you are doing some vision based application, for example, then you can create a driver package for accessing the camera data. Then you can create a package for doing some vision processing like face detection or like motion detection or some other things. Okay, so that can be another package. So by creating the separate package will make the entire project very modular. Okay, so if you want to work with a complex project, just create a workspace and then keep on creating the packages for specific purpose. So that is what we have to do. So you can keep a library inside a package. You can create the nodes inside the packages. You can create launch files, parameters, everything inside the package. So I mean, it's like single project, I will say. Each package we can consider as a project. So yeah, so that is what. Is that clear, or you need more clarification? Okay.
Yeah, it makes sense.
Okay. So any more questions? So if you have any question, like maybe later, you can just put it in the group. No need to worry about, or you can just DM me, no problem. Okay, so next day, maybe Sunday night or something, we can discuss about ROS Pi. Okay, ROS Pi, I think it's already there in my some of the package. Yeah, this one. Okay, and one more point, there is no just a second, the workspace was learn ROS, right? Learn ROS. Okay, so there is no mandatory mandatory structure, like we can rename the SRC folder, no problem. You can give a name, no problem. But this is a common convention that we are. So if we change the SRC into test or something, just change the location here. Instead of SRC, you can give test / something. Okay, so I mean, most of the stuff are like conventions. Okay, but it's not mandatory. That's it. Okay, and like for a workspace, it will be better to give the _WS. So it is indicating that it's a ROS workspace, like that. So this is a common convention to make our life easy, I will say. Yeah. Yes, and you can able to see the executable in the devel folder. Like if you go to lib or share, not into share, to lib, you can able to see the executable of the hello world package. Then you can see the learn ROS package and its executable. Okay, so this is where the executable forming, and you can simply execute it without the ROS run. You can also do that. For example, if I do the Docker test, it will still work. Okay, but the advantage of ROS run is that you don't need to / everything. Imagine you are in the home folder, so you can simply execute using ROS run if you know the package. Okay, that is more I will say convenient, right? So that is what. So there is no strict or mandatory need of running ROS run. You can execute like using /. Also for the Python, you can simply execute using /. That will also work. Okay guys, I think we can conclude for today, and tomorrow or maybe day after that we will be discussing the ROS Pi. Okay, we will be seeing, and then after that we will be discussing services, parameters, those kind of stuff, the implementation of that, and then we will be discussing the turtle sim based programming. Okay then, thanks for attending today's session. I will be uploading the video, maybe not by today. I will be uploading the video, but yeah, maybe I can share the video link only, okay, because tomorrow I have the workshop. Okay then guys, good night, and see you next day. Okay, bye everyone. Yeah, bye.
Thank you.
Bye.
Bye.